I think it's now started. Good morning, folks. We have short and sweet notes today. We're going to be focusing on two things. So what we're really trying to do is undo exponential equations, or we're solving exponential equations. So the first thing we need to know is that exponents and logarithms are inverse operations. We knew that from last time, from our notes before. And they can cancel each other out if the bases match. Okay, so if we have our equation, I'm going to use pink for our base. So if I have B E equals A, you remember that log form is the same thing, would be log base B of A equals E, which is B. Okay, so B is our base in both of those. So if those two things match, then they're able to cancel each other out. So as we look at this first example here, I'm going to have to zoom in because that's pretty far away. Focus. Okay, so if we look here, I've got 10 log base 10 of x. So here I have a base 10. We're going to stick with pink, maybe. We have 10 and 10. So I have a base of 10 to an exponent of log base 10. So this is the exponent base and this is the log base. So because those two things match, the log goes away and we're left with just an x. Okay. Here I have log base 5 of 5 to the 3x. So my exponent's base is 5 and my log base is 5. So 3x is what we're left with. If we want to take it one step further, if you remember before, we've got, this is the same thing as asking 5 to the what equals 5 to the 3x. And that should be obvious that 3x is what we end up with there. All right, I would go ahead and pause here, see if you can do the next one on your own, but I'm going to go ahead and do it. So we've got 6 to the log base 6 of x minus 2. The 6's match. They're both their bases, so then we're left with x minus 2 for that one. For this last one here, oops, well, we'll turn those notifications off. Apparently he's done with Gale for today. Okay, so let's go ahead and rewrite this because we don't have the same base. 2 and 16 are the bases. So what I have to do is I'm going to rewrite this as log base 2 of 2 to the 4th x. Because 2 to the 4th is 16, and that x stays. So if you remember from last chapter, 2 to the 4th to the x would be 2 to the 4x. This is a very bright pink marker. And of course, that's out of frame. Switch over a little bit and down. There we go. Okay, so now we have the same base of 2 and 2. So the log goes away and we're left with just 4x. Okay, and so we have all of these properties of logs. We've got general properties and then common logs and stuff like that. And all of these come from this rule up here, that if exponents and inverse operations, they're going to cancel out if the bases match. So each and every one of these comes from that rule there. So these are nice to have if you want to kind of make some shortcuts. All right, moving into the second part. I don't know how long this video is, but hopefully it's under 10. All right, so we're gonna find the inverse. In finding the inverse, we have to do two things. One, we have to switch x and y. And 2, we need to solve for y again. So that is how we find the inverse. Our first example here, I'm going to zoom in nice and tight so you can see, maybe. She's finicky. Okay, it's a little blurry, but hopefully you can see that okay. So first we need to switch our x and y. So step 1, switch our x and y. That becomes an x log base 4 of y. So all we did was switch the x and the y. Wherever there was an x, we put a y. Wherever there was y, we put an x. Step 2, we need to solve for y. So I need to get y by itself. We have bay here, but our e's over on the other side. So let's go ahead and put it into exponential form, because when we're trying to solve these, that's what we're going to do. So we have base exponent equals our answer. We have to ask ourselves, is y by itself? It is. So this right here is the inverse. If you feel confident, pause, go ahead and do the rest of them. If not, just keep following along with me. Okay, so for this one, I have y equals ln of x minus 2. First thing I'm going to do is I want to write this in terms of a log. So this I'm going to write is y log base e of x minus 2. That way it's something we're more familiar with. Can barely see that. Okay. Now I'm going to do step 1. I'm going to switch my x and my y. So y becomes x becomes y. I've got to unbay it again. So this is b. This right here is a, and this is e. So this whole thing is a. So when we put it as our answer, that whole thing is going to move to the other side. So then step 2, pink marker, we have base to the exponent gives us our answer. And I ask myself, is y by itself? No, so we have to add 2 to both sides. Go ahead, put our thing here. Add 2 to both sides. I get e to the x plus 2 equals y. I'll go ahead and rewrite that a little bit neater. The bottom here, type e to the x plus 2 equals y as our answer. All right, again, if you feel comfortable, go ahead and move on to the next couple. I'm going to keep moving along here. My face is in the way. Moving to the right here. Okay, so I have y equals 7 to the x. Before we were in log form, now we're moving from exponential form. The steps are still the same though. So first, I need to switch my x and my y. So I have x equals 7 to the y. The hair somewhere. Here is my base, my exponent, and my answer. So I have gonna bay it, so that's I'm blanking. It is going to be log base b of a equals e. So that's bay. All right. We ask ourselves, is y by itself? It is. So this right here is our answer. That was step 2. All right, let's do our last example. I have y to the 2x minus 3. Okay, so step 1, let's switch our x and our y. So I have x equals 2 to the y minus 3. Make sure you don't put that -3 in the exponent because it is not a part of the exponent. It's separate. Also, make sure you're not writing this too big. This is getting to the point where it might be a little bit too big to be an exponent, but it's high enough that we know that it's not. So step 1, we're done. Step 2, we have to isolate y. So I have a 3 here. I'm going to go ahead and add that to the other side. So I get x plus 3 equals 2 to the y. And I have to undo this exponent. And in order to undo an exponent, we have to use a log. So I have this right here is my whole A. This is B and E. So I end up with, I'm going to come down here. Sorry about that. Move myself over a little bit more. So I have log base B of A equals E. Y is officially by itself, and so this right here is our answer. Okay. Sorry I ran out of room there. We're all done. Your homework assignment is page 457, 46 through 52 even, 62 through 68 even. Don't forget to post those pictures to Google Classroom when you're finished. Have a great day. Catch you on the flip side.